gases, and we're going to talk about one type today in this lesson. Okay, whenever we're dealing with something and we're trying to figure out how we are supposed to name it, the first question we ask is there a metal? If there is, then we have to ask a second question. Is it a transition metal? In this instance, this first set of lesson, we are going to say no, there is not a transition metal, but there is a metal. We call that a type 1 binary ionic compound. Ionic compound because we're dealing with ions. What we do when we name it is we list the name of the metal first, and then we use the nonmetal's name, but we put IDE at the end. For instance, NaCl is sodium chloride with the common name table salt. Na, sodium, Cl, chlorine, but again we put IDE at the end, chloride, sodium chloride. The next one, CaBr2, we have calcium, Ca, and bromine, but it's a compound, so we have to do IDE at the end. It becomes bromide, calcium bromide. Al2O3 means that we have aluminum oxide. Type 1 binary ionic compounds sometimes have polyatomic ions and not just a regular non-metal as the anion. So we'll list the metal first, and we don't add "ide" to any polyatomic anion because they already have their special names, which you memorized before the school year started. Or we list the polyatomic cation first, which the only one we've spent our time memorizing is ammonium ion. We just wouldn't list the ion in that part because now it's in a compound. And then we do the non-metal anion with IDE at the end, unless it's another polyatomic anion. So for instance, we have Ca3 and then in parentheses PO4 parentheses 2. We have calcium, that's our metal. It's not a polyatomic cation, so it's just calcium. And PO4, if you remember back, that is the phosphate ion. So we call this calcium phosphate. NH4Cl, that's the one that I was talking about with the polyatomic cation. That is ammonium. And then chloride. Because it's no longer chlorine, it's now part of a compound, so it is chloride. Okay, if we have the name, but we want to write the symbol, we have to use what's called the crisscross method, which we haven't discussed in this lesson, but we will discuss often. So for instance, we've got magnesium chloride. We look at the charges from the periodic table. Mg, magnesium, is an alkaline earth metal. It's in the second column, so it has a 2+ charge. Chlorine is a halogen. It's in the 17th column. It has 7 valence electrons, so it just needs one more to be electronically like the noble gas argon. So it is going to gain 1 electron, so it's a 1 negative charge. And then what we do is we crisscross those down. I need 2 Cl's for every 1 Mg to get the charges to even out. So I would have 2 times the chlorine, which is 2 times a -1, that's -2, and that would cancel out with our 2+. 2+ minus 2 is 0. So I have an electrically neutral compound. Ammonium phosphate. Okay, we've got 2 polyatomics here. Ammonium is NH4, and if you remember back, it has a 1+ charge. Phosphate is a PO4, and it has a 3 negative charge. So what this is saying is I need 3 of my ammonium ions to go with my 1 PO4 phosphate ion. But I have to remember that that whole ammonium gets that 3. If it didn't, then I would just have 12 hydrogens, which doesn't neutralize us out. So I put my NH4 in parentheses, put the 3 behind it. I've crisscrossed it down. PO4, I don't have to write the 1 behind it because it's just a 1. So I get parentheses NH4 parentheses 3 PO4. And this is just, again, saying that ammonium is a group, so the entire group must get that 3 charge, because it's that entire group that has a 1+ charge. That's why we put it in parentheses.